Hi, here we go. We are on our next unit, quadratic functions. Quadratic functions is a big unit, and this is day one of this next unit. So the first thing that we're going to do is talk about solving quadratic equations. So a quick reminder that a quadratic is ax squared plus bx plus c. So that is the standard form for a quadratic. The equations, remember, equations have to have an equal sign, so they will have an equal to 0 that we're working with. So our objective is to find quadratic solutions. Quadratic solutions are also known as roots, zeros, x-intercepts. We'll do it by factoring rather than graphing. We did, finding x-intercepts at the first half of the school year. So if you remember, if I gave you a coordinate plane and you had, let's say, a parabola, it's right here where they intersect the x-axis, and that's what we're solving for today by factoring, okay? So our steps to do this is we're going to make sure that the polynomial is set equal to 0, okay? So called the 0 property, having it set equal to 0. We're going to factor the polynomial completely. Then we'll set each factor equal to 0. Then we'll solve the equation for the variable, and then check our answers by using the original equation. Okay, so this first example, I take a look at this, make sure it's set equal to 0, and it is. And then the next thing that we're going to do is factor completely. So similar rules as before is we are going to think of factors of c, so negative 24, that would add to our b, which is negative 5. And so we have our two binomials, drop down that equal to 0. We'll go ahead and use negative 8 plus 3. Then our next step says to set each factor equal to 0. So a minus 8 equal to 0, a plus 3 equal to 0, and then we keep solving. So we'll add 8 to both sides. We have a is equal to 8, subtract 3, a is equal to negative 3. Okay, and these are my two answers. These are the solutions to the quadratic function. So real quick, I'm going to check and see if I have a more sharpened pencil. I seem that I don't. So unfortunately, you have to wait a quick second while I sharpen this. Couple of seconds. There we go. Hopefully that'll work better. So let's go ahead and try our next one. So our next one, what we're going to do here is make sure it's set equal to 0, and it's not. So to set it equal to 0, we're going to subtract 45 from both sides. And then we end up with y squared minus 45 is negative 4y minus 45 now equal to 0. And so we'll go ahead, since it's now equal to 0, factor this. So we'll go ahead and use that trinomial factoring that we did in class. So factors of negative 45, that would add to negative 4. And so we'll go ahead and use y minus 9, y plus 5. Our next step is we set each factor equal to 0. Then we solve for y. And these are my two solutions for A. Let's go over to B and take a look at B. So for B, I have this one set equal to 0, but you know what I do notice is I notice that I have a GCF. So we can still do we need to still do GCF factoring when we are factoring completely. So I'm going to go ahead and factor out a 3. Okay, so that's my GCF. I'm left with x squared minus 2x minus 8 equal to 0. My next step will keep factoring, so the trinomial factoring. So factors of negative 8 that add to negative 2, that'll be x minus 4, x plus 2. Then we're going to set each factor equal to 0. So even my GCF will get equal to 0. And we'll see that 3 does not equal to 0, but we are going to do that because sometimes down the line, when we factor, it'll be a variable and not a number, and that variable will be equal to 0. So we'll go ahead and keep solving for x. And so my two solutions, x equals 4, x equals -2. Okay, we'll go ahead and try C. So C, again, let's take a look at this one and notice that we do have another GCF. We have an x, so we're going to factor out the x, and then we're left with 7x squared plus 2x minus 5 equal to 0. We're going to keep factoring completely, so our trinomial factoring. What's nice is A and B are both prime. So I'm going to go ahead and have one binomial with the 7x, the other one with the x. So I have to think of factors. When I multiply them together, I get that positive 2. So I know if I have a 5 here, I'll get 35. That's too big. So I need to have a 5 here, 1 there, and then just think about my sign. So 7 times 1, I want that to be positive. 5 times x, I want that to be negative. Drop down that equal to 0. My next step, we're going to go ahead and set each factor equal to 0. So it's going to be x equals 0. 7x minus 5 equals 0. X plus 1 equals 0. And we're going to keep solving. So x equals 0 is one of my solutions here. So I'm going to circle that in. My other answer, x equals 5/7. We're going to leave our answer as a fraction. We aren't going to write it as a decimal unless it ends exactly. We aren't going to round. And so 5 divided by 7 does give you a crazy decimal. I don't want answers like that. And the last one, x equals -1. All right, let's go ahead and try D. So for D, again on this one, I need to make sure that it's set equal to 0. So I'm going to start by subtracting 40 from both sides. So I have x squared plus 5x minus 36 equal to 0. Factors of -36 that add to 5. Okay, I'm going to have x plus 9, x not minus 5, minus 4. Okay, now I'm going to go ahead and set each factor equal to 0. So just solving for x. And my two solutions, x equals -9, x equals 4. Okay. Let's go ahead, same thing for E. We're going to set this equal to 0. So I have x squared minus 6x minus 55 equal to 0. And then from here, we're going to factor. When I factor, factors of -55 that add to -6, x minus 11, x plus 5. Then we set each factor equal to 0. Then we solve for x. So at this point, you guys kind of see, well, x is 11, x equals -5. That's fine. You do not need to show that little bit of work right here that we were doing on some of the other ones. Okay, but you are required to set each factor equal to 0. I do need to see that work. So right here on E is the minimum amount of work allowed. Let's go ahead and do F. F is another one that, again, we want to make sure set equal to 0. So a few steps to move variables and terms to the other side of the equal sign. So we'll go ahead and add z to both sides. Then I'm going to go ahead and add 2 to both sides. And when I do that, okay, I will have it set equal to 0. I'm going to have 2z squared. And then I have this plus z. Then I have 2 and a -3. That'll be -1 equal to 0. Okay, now we're going to have to factor. A and C are both prime numbers. This makes it a little bit easier, so I know I'll have 2z and then z. And then for 1, my only option is 1. Now I just have to think about sign, so I get a positive 1. So right here I have to have a positive, and on my first factor a negative. So 2z minus 1 and then z plus 1. Then we have to set each factor equal to 0. Then from here, we solve for z. So I have z is equal to negative 1. That is one of my solutions, one of my x-intercepts. So remember, this is an x-intercept. I'm going to go ahead and add 1 to both sides. So I have 2z is equal to 1, and then z is equal to 1/2. Now, if you wrote this as 0.5 or 5/10, that's fine, or fraction. All right, so the back, if we flip it over, this has more examples and just a little bit of special cases. So we'll do that together next time I see you in class. Okay, that's it for these notes.